Welcome back. In front of us, we have a quadratic graph problem. Question A, copy and complete the table of values y equals to 5x squared plus 2x minus 39 for minus 4 less than or equals to x less than or equals to 4. Solution. Question A, we are instructed to copy and complete this table for the quadratic equation y is equal to 5x squared plus 2x minus 39 for the range between minus 4 and plus 4. So this is the table that we have between minus 4 and positive 4. We are going to use the formula y is equal to 5x squared plus 2x minus 39 to complete this table. When x is equal to minus 4, by substituting its value into the equation, we will have y is equal to 33. When x is equal to minus 3, y is equal to 0. We can confirm that when x is equal to minus 2, y is equal to minus 23. When x is equal to minus 1, y is equal to minus 36. When x is equal to 0, y is minus 39. We can confirm that when x is equal to 1, y is equal to minus 32. When x is equal to 2, y is equal to minus 15. When x is equal to 3, y is equal to 12. And we can confirm that when x is equal to 4, y is 49. So that is question A. Moving on to question B, it says, using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 10 units on the y-axis, draw the graph of y is equal to 5x squared plus 2x minus 39 for minus 4 less than or equal to x less than or equals to 4. We are going to use the values that we have here and plot a graph of y is equal to 5x squared plus 2x minus 39 using the given scale. In front of us is the graph paper. We will indicate the x and the y-axis. So this is the x-axis and this line is the y-axis. We are instructed that we use 2 centimeters to 1 unit on the x-axis. From the origin on the x-axis, that is 0 here, we count our first 2 centimeters and we indicate 1. Then afterwards, we will be adding the same value. So when we add 1 to 1, that will be 2, then 3, then 4, then 5. We can do the same thing on the opposite side, but it will be negative. So we have negative 1, negative 2, negative 3, negative 4. Okay? That is the x-axis. On the y-axis, we are instructed to use 2 centimeters to 10 units. So it means from the origin on the y-axis, we count our first 2 centimeters, then we're going to indicate 10. Then afterwards, we'll be adding 10. So we're going to have 20, 30, 40, 50, 60, and so on. That is the y-axis. We can do the opposite, which will be negative values. So we have minus 10, minus 20, minus 30, minus 40, minus 50. So coming back to this table, we are going to plot the values of x against y on our graph. From the table, when x is equal to minus 4, y is positive 33. Because we have 2 centimeters to 10 units on the x-axis, it means each small box is 1 unit. So to locate 33, that will be 3 boxes from 30. Now what we're going to do is we're going to make these 2 points to intersect. -4 on the x-axis and 33 on the y-axis. The point of intersection for these 2 values is here. Moving on, when x is equal to -3, y is equal to 0. So that is exactly at this point here. When x is equal to -2, y is equal to -23. So that is 3 small boxes from -20 below. That is this point here. When x is equal to -1, y is equal to -36. So that is 6 small boxes from -30 at this point here. When x is equal to 0, y is equal to -39. That is 1 small box from -40. Okay? A box before -40. That is exactly here. When x is equal to 1, y is equal to -32. That is going to be 2 boxes from -30 below. When x is equal to 2, y is equal to -15. That is at this point here. Okay? When x is equal to 3, y is +12. So +12 is 2 small boxes above 10. So the exact point is here. And finally, when x is equal to 4, y is +49. +49 is 1 box before 50. So after indicating the points correctly, we are just going to use a smooth curve to join the points. So this is the graph. Y is equal to 5x squared plus 2x minus 39. Question C reads, on the same axis, draw the graph of y is equal to 6x minus 11. Well, this equation is different from the primary equation that is given to us. In fact, it is a linear equation. We have to plot the graph for this equation as well. There is no table that is given for it. So what we are going to do is to create a table for ourselves between the range of -4 and +4. You can select any 3 to 5 values of x. So question C, I'm going to bring a table, and this is my table. I want to know the value of y when x is -4, -2, 0, 2, and 4. Knowing these values will help me draw the linear graph of y is equal to 6x minus 11. So by substituting the values of x into the equation, we are going to have y is equal to minus 35 when x is equal to minus 4. When x is equal to minus 2, y is minus 23. When x is equal to 0, y is minus 11. When x is equal to 2, y is equal to 1. When x equal to 4, y is 13. So let's move on to plot these values on the graph. From the table, when x equal to minus 4, y is equal to minus 35. So the point of intersection is here. When x equal to minus 2, y is minus 23. That is exactly at this point here. Okay? When x equal to 0, y is minus 11. Minus 11 is one small box below minus 10. So that is at this point here. When x is equal to 2, y is positive 1. That is just one small box above the horizontal line, okay? Because each box on the y-axis is 1 unit. So that is this point here. And finally, when x is equal to 4, y is positive 13. Positive 13 is 3 small boxes above 10. So that is the point here. Now let's join the points with a ruler. And that is the graph of y is equal to 6x minus 11. Question D. Use the graph to find the roots of the equation y is equal to 5x squared plus 2x minus 39. That is question D. We want to find the roots of the equation y is equal to 5x squared plus 2x minus 39. This is the given equation. If we compare it with the parent equation, we realize that there is no difference. So whenever you have such a situation, you find the roots of the equation at a point where the curve cuts the x-axis. Let's try to demonstrate that on the graph sheet. So this curve is the graph of y is equal to 5x squared plus 2x minus 39. We want to find the roots of this equation. It is where the curve cuts the horizontal line, okay, the x-axis. And it is at 2 points. One of them is minus 3, and the other one is here, which is 2.6, okay? So which means the roots of the equation are x is equal to minus 3 and x is equal to 2.6. And these are the same values that you expect to have if you should solve this quadratic problem using the formula method or the factorization method or the completing the square method. That is the answer for question D1. Providing answers for question D1, the roots of the equation y is equal to 5x squared plus 2x minus 39 is that we have two values of x. We can say x is equal to minus 3 and x is equal to positive 2.6. Question D2, we want to use the graph to find the solutions for the equation 5x squared plus 2x minus 49 is equal to 0. So this is a quadratic equation that is somehow different from the main equation. So we need to compare both, and that is what will tell us what we need to find. Now, what we're going to do is we are going to bring the main equation first, which is y is equal to 5x squared plus 2x minus 39. And we compare it with the equation that is given in question D2, which is 5x squared plus 2x minus 49 is equal to 0. We have the second equation as 5x squared plus 2x minus 49 is equal to 0. Okay, we can bring the 0 to the left side of the equation. It means the same thing. We are now going to compare these two equations. And what we will try to do is to see how we can eliminate some terms in both equations. Now, if I ask you, what should I do in order to facilitate elimination here, is that I have to use subtraction, okay, such that 5x squared minus 5x squared will be 0, 2x minus 2x will be 0. So we're going to have minus 39 minus 49. If we do that, we are going to have positive 10. And for this side of the equation, y minus 0 is just y. So that is to say we're going to have y is equal to 10. So we will now go to the graph and look for the values of x when y is equal to 10. This is the graph. Y is equal to 10 is at this point, so we are going to bring dashed lines to touch our graph. So as you can see, this is where y is equal to 10. And what are the two values of x that we have from that point? We're going to trace them to the x-axis. One of them is minus 3.3. Let's indicate that. As you can see, that is the value of x. And the other one is from here, if we trace it to the x-axis, that is about 2.9. So which means we have now found the solutions for y is equal to 10. One of the values of x is minus 3.3 and the other is 2.9. To provide the complete answer for question D2, we will say when y is equal to 10, x is equal to minus 3.3 and x is equal to positive 2.9. Question D3 is asking us the solutions for the equation y is equal to 6x minus 11. So this linear equation is again going to be compared with the main equation from the graph. The point where the two graphs intercepts will give us the solution. Let's trace that from the graph. We have the two graphs here. One of them is quadratic, the other one is linear. These two graphs intercepts at 2 points. One of them is here and the other one is here. So what are the values of x for this solution? Here, if we trace it to the x-axis, we will have x is equal to minus 2, and for the other one is x is equal to 2.8. Okay, so the answer to question D3, we're going to say x is equal to 2 minus 2 and x is equal to 2.8. Question D4 is asking us to find the equation of the line of symmetry. The equation of the line of symmetry is basically the value of x where the graph is divided into two equal parts. What is the line that we can introduce to this graph that is going to divide this graph into two equal parts? So this line that we have is what is going to divide the graph into two equal halves. I hope you agree with me on this. That is where x is minus 0.2. Okay? So the equation of the line of symmetry is that x is equal to minus 0.2. Okay? It is the point where we can divide this graph into two equal halves. X is equal to minus 0.2. Question 4. The equation of the line of symmetry is that x is equal to minus 0.2. We can be able to determine this with the main quadratic equation that is given, which is y is equal to 5x squared plus 2x minus 39. If we use the general quadratic equation, which is y is equal to ax squared plus bx plus c, by comparing the two, a is equal to 5 and b is equal to 2. We need to determine the value of a and b to be able to determine the equation of the line of symmetry. It is given as x is equal to minus b divided by 2a. So that is going to be minus b is positive 2 divided by 2 times a is 5. So that is minus 2 divided by 10. And that will give you the value of x as minus 0.2. The final question is asking us to find the gradient at x is equal to 2. Okay, so how do we do that? This is the graph. We want to know the gradient, which is also called the slope, but we are given the point x is equal to 2. So we will trace that to the graph, that is this point, and we then draw a tangent. A tangent is a straight line that touches a curve at just a single point. So let's try to draw our tangent. The tangent that we are going to draw is going to be a line that is going to pass through x is equal to 2. Okay? So this is the tangent, and you can see it has touched the graph or the curve at x is equal to 2. Now what we're going to do is we are going to select 2 points on this tangent. Let's say one of the points is here and the other point, let's say, is here. So the point here, we can call it x1 and y1. So what will be the value of x and y from this point? X is 1.5, that is x1 is 1.5. From that same point, what is y1? Y1 is 6 small box from minus 20. That is going to be minus 26. Moving on to this point here, x2, y2. So what is the value of x2? The value of x2 is positive 3. And from that same point, what is the value of y? Y is positive 7. Okay? So with these values, we can be able to find the gradient of the graph. Question 5. The gradient at x is equal to 2. We use the letter m for gradient is equal to the change in the y divided by the change in the x values. So that is to say the gradient is equal to y2 minus y1 divided by x2 minus x1. Remember, x1 and y1, we have the values as 1.5 and minus 26. For x2 and y2, we have the values as 3 and 7 respectively. So gradient is equal to y2 is 7 minus y1 is minus 26 divided by x2 is 3 minus x1 is 1.5. We will have the gradient is equal to 7 plus 26 divided by 3 minus 1.5 is 1.5. So the gradient is equal to 7 plus 26 is 33 divided by 1.5. The gradient is equal to 33 divided by 1.5 is 22. If you are doing calculus, you can be able to determine this value using differentiation. So again, we are going to use the main equation of this graph, which is y is equal to 5x squared plus 2x minus 39. So how do we do the differentiation? The rule is you will take the power that you have here, multiply it by 5, and then the power will reduce by 1. Okay, so we can say dy divided by dx. We are differentiating, so this is equal to 2 times 5x to the power 2 minus 1. Again, what I did, I took the power 2, multiplied by 5, then that 2 is reduced by 1. Plus, for 2x here, we can say that the power of x is 1, okay, because anything to the power 1 is the same. So, to do the differentiation, we're going to say 1 times 2x to the power 1 minus 1, because the power of x has to reduce by 1. So that is 1 times 2x to the power 1 minus 1. For the minus 39, just forget about it, okay? Because the differential of a constant is 0. Moving on, we can say dy divided by dx is equal to 2 times 5x to the power 2 minus 1 is 1, so we just leave it like that, plus 1 times 2x to the power 1 minus 1 is 0. So the power of x becomes 0. dy divided by dx is equal to 2 times 5x is 10x plus 1 times 2 into x to the power 0 is 1. Okay, anything to the power 0 is 1. So dy divided by dx is equal to 10x plus 2, because 1 times 2 times 1 is just 2. So after reaching at this point, we can substitute the value of x to know the gradient. Remember, the question says that the gradient at point x is equal to 2. So that is dy over dx is equal to 10 into 2 plus 2. So dy divided by dx is equal to 20 plus 2. dy divided by dx is equal to 22. So you can be able to use this differentiation to know whether your gradient is closer to this answer or not. Do not stress yourself if you don't have the exact gradient as the value that you will have from the differentiation. Whenever you have a closer value, the examiners usually will give you the marks that is required. And for the graph, again, I want to emphasize that some examiners always would like the students to write the title of the graph, okay? So we can say the graph of y is equal to 5x squared plus 2x minus 39 and y is equal to 6x minus 11. So that is all for today. Thank you for watching this video.